Sarthak from the 3S TUTBUDDIES. Today I'm going to teach you the basic mechanics. And to learn the basic mechanics, first you have to know the chapter, the laws of motion. In this chapter, before going into it, you have to know some normal physical quantities. The quantities are like distance, displacement, velocity, and acceleration and momentum. So first, distance. Distance is denoted by d, is a scalar quantity. Let A be a point and B be another point. Let a person goes from A to B in this way. So in this case, the total path covered by the person while going from A to B is the distance. The next thing is displacement. It is denoted by S. It is a vector quantity. In the same figure, let us draw a line from A to B. In this picture, AB is the shortest distance between A and B. The displacement is the shortest distance between two given points. So in this case, the displacement S is AB. The next thing is velocity. Velocity is denoted by V. It is also a vector quantity. Velocity is the rate of change of displacement with respect to time. So you can write V is equal to derivative of S displacement with respect to time. So V is equal to ds by dt. The next thing is acceleration. It is denoted by A. It is also a vector quantity. Acceleration is the rate of change of velocity with respect to time. So you can write acceleration A is equal to dv by dt. The next thing is momentum. It is denoted by P. It is also a vector quantity. Momentum is the dot product of mass of a body to its velocity. Let this is a point A and this is a point B in a body of mass m is moving from A to B with a velocity v. So we can say the momentum of the body P is equal to m dot v. And the next things are the laws of motion. These laws are given by Newton. There are three laws. According to the first law, if a body is at rest or moving with a uniform velocity, it will move in that way until an external force is applied on it. That means the body will have no acceleration. Let this is a body of mass m. It is having a velocity which is constant or equal to 0. If no force is acting on it, then it will move in this way and the acceleration will also be 0. According to the second law, the force can be written as F is equal to ma, where m is the mass of the body and A is its acceleration. Now let us derive it. There is a relation that the rate of change of momentum dp by dt is directly proportional to the force. So you know P is equal to mv. So you can write force is equal to dp by dt, which is m dv by dt. As you know, dv by dt is acceleration a, so hence derived force is equal to mass into acceleration. Now the third law. According to the third law, every action has an equal and opposite reaction. By means of equal, it means the magnitude will be same, and by opposite, it says that the direction will be opposite. Now let me give an example. Let this is the ground, and this is a person who is standing on the ground. Now he is pressing against the ground with a force of F. So in return, the ground will give him a force which is known as normal force. So you can write N is equal to F Now let us know the types of forces. The types of forces you will get to know in this chapter are tension force, gravitational force, and the third one is normal force. First, tension force. This is a force which comes into act in the ropes or in the chains. Now let me show you a diagram. Let this a roof, and this is a rope. This is the body of mass m hanging with it. So the gravity will act on it. The gravitational force is mg. So the tension is T in the rope. The tension force always acts away from the body, so you can write T is equal to mg. The next one is gravitational force. The gravitational force is the force, it is the weight of the body. You can say if this is a body of mass m, then its weight will be m into acceleration due to gravity g. So mg. This is the gravitational force. And the third one is normal force. This is the force which is exerted by a body when the body is pressed against another body. Let me give an example of this. If this is a body of mass m, then it is giving a normal force N1 to the ground, and the same, the ground is giving it is a normal force N2. So according to the law, N1 is equal to N2. Now let me give you another example. This is an inclined surface. There is a ball here. So the ball will be exerting normal forces from this side and this side. These are the normal forces exerted by the ball and given by the walls. Now the next thing is free body diagram. The name itself says that the body will be free. The body will be free from all the forces. So it is a practical way to resolve the forces and know how the forces are acting on the body. Let me give an example. This is a roof, this is the rope, and this is a ball of mass m. Another rope like this is there, it is making an angle of 45 degree with the horizontal. Let this is 45 degree. So if we resolve this diagram, you can see this is the point M. The forces acting on it are the mg force, one tension force, and one another tension force T dash in 45 degree angle. Now let us resolve the forces in the horizontal. Horizontally resolving the forces, we get there is only one force acting horizontally, that is T dash cos 45. You can write T dash by root 2. And now resolving the forces vertically, you can write the downward forces first, mg, this is the only downward force, and the upward forces T plus T dash sine 45. You can write mg is equal to T plus T dash by root 2. Now let us do some block problems. Let this is a surface and this is a body of mass 2 kg. There is a force, it is a rope, and the force is 20 Newton. So by resolving, we can say that the force F is equal to mass of the body into its acceleration. So the force is 20 Newton, mass is given 2 kg into acceleration, so the acceleration will be 10 meter per second square. This is an easy one. Now let's do another. Let this is a body of mass 5 kg. There is another body on it of mass 2 kg. The lower body is pulled with a rope of force 50 Newton. So we can assume that the two bodies are going with the same acceleration. So we can assume that the two bodies are one body. So the total mass m is equal to 2 kg plus 5 kg is equal to 7 kg. So the total force 50 is equal to m 7 kg into acceleration. So the acceleration will be 50 by 7 meter per second square. And if the upper body goes in its own way, then there are some different parts. Those are called the inertia of reference, the inertial frame. We'll be teaching you about that in the next episodes. Hope you liked the video. Keep subscribing, keep learning, and help us grow.